Hello everyone, in this video tutorial let's go through overview of RF wireless communication blocks. So this RF wireless communication block diagram is similar to that of the communication block diagram studied in information theory and coding. And in information theory and coding we know that it involves two kinds of encoders. One is the encoder part consists of two encoders. One is source encoder and the other one is the channel encoder. So source encoder can also be thought of as data compressor, where redundant bits or extra bits or the correlated bits are actually eliminated. So this thing exploits the correlation between the data and try to minimizes the redundant bits, and after doing that it gives out the output as source code word, and in turn this source code word also has control bits associated with it, and after passing it through this channel encoder tries to convert the data bits received in a suitable manner so that it can easily be modulated, and depending upon the channel characteristics it tries to add a few more parity bits so as to combat the error within the wireless channel. So after adding the parity bits, it is in turn this entire thing containing the data bits, control bits and parity bits are in turn sent to the modulator, where some modulation scheme will be used, and RF waves will be generated and will be passed to the antenna stage, where it can propagate via the air medium in between, and here the RF wave will be received and it will be demodulated, and in turn that will be given to this channel decoder, and in turn after assessing the received bits, so it is in turn given to the source decoder. So here source encoder and decoder corresponds to the application layer of OSI model, and from channel encoder to the modulator as well as the channel decoder and demodulator, these all things constitute the physical layer. So because right now we are trying to discuss RF wireless communication blocks, so that is why we have started only from the source encoder, and we are not starting right from the information source or here with the destination. The following are performed to transmit information between a transmitter and a receiver. Source encoder or data compression. At the transmitter and the information source is first encoded with source encoder, which exploits the information statistics to represent the source with fewer number of bits, that is source code word. Source coding is referred to as data compression. Channel encoding, error control coding. So this source code word is then encoded by the channel encoder to address the wireless channel errors affecting the transmitted information. The channel coding is also referred as error control coding, and it also involves in between process called as interleaving and modulation. In interleaving, the encoded channel symbols are then interleaved to combat the bursty errors that can affect a large number of consecutive bits. Followed by modulation, the channel coding and the bit and the interleaving mechanism help the receiver either to identify the bit errors in the initiated transmission or correct the limited number of bits in case of an error. So both identification and correction are being done. These interleaved bits actually help with error identification and error correction. Then an analog signal or a set thereof is modulated by digital information to create the waveform that will be sent over the channel. Finally, the waveform are transmitted through an antenna to the receiver. Wireless channel propagation. The transmitted waveform, which is essentially an electromagnetic wave, travels through the channel. Meanwhile, the waveform is attenuated and distorted by several wireless channel effects. So here is a diagram that which shows the source and channel coding. As you can see here, this source stream actually contains lot of correlated bits, and these correlated bits will be removed when passed through this source encoder. So this thing exploits the statistics property of information from the source, and this unit is also called as data compressor. And then we get source code word, wherein control bits have already been added, and then this source code word will be made to pass through this channel encoder, where it exploits the statistic properties of the channel So because of which it adds some parity bits. So this channel encoder block exploits the statistical properties of the channel, and depending upon the statistical property of the channel, it is adding the parity bits. And this channel encoder is also called as error control coder. So this is about the overview of RF communication blocks. And in our next video, let's go through sources of distortion in wireless communication.